All right, here is our test review answers, guys. So make sure you watch this. Ask me questions over the weekend. If you have any, just send me an email. And there's also the extra help session. On Monday at 3 o'clock. I sent you guys the link in a Canvas message. So if I look here in this first example, 1A, we talk about domain. We're going to look from left to right. So the furthest to the left we go is -5, and that's going to have a bracket because our circle is closed in, so it's -5. And then the furthest to the right we go is +6, and again that's going to have a bracket as well because it's closed. If we're looking at the range, we read from bottom to top. So I look at the bottom. The lowest this graph reaches is -4, and your circle is open, so we're going to have a parenthesis. And the highest that this graph goes is 16. So you'll have 16 and you'll have a bracket because that dot is closed. If we're talking about intervals of increase, decrease, and constant, we read from left to right. And guys, remember, we read intervals of increase, decrease, and constant on the x-axis. So from the furthest right we start here, and if I follow my line, it goes downwards. This would be an interval of decrease. And it's going to be from -5 to +1. And then if I put my pencil here and I follow my line upwards, we are going to go from, an increase would be from +1, to 6. If we talk about an interval of constant, there is not one. So on your test, I would like you guys to write the word none or no constant, anything like that. Don't just leave it blank. All right, for letter B, same thing. We're going to read domain from left to right. I have arrows on both sides of my graph, so my domain is just going to be -infinity to +infinity. Our range, remember, we read from bottom to top, so down here would be -infinity, and the highest this goes would be 4. And I have my bracket. For increase, decrease, and constant, starting from, remember, we read intervals of increase, decrease, and constant on the x-axis. So we start over here at -infinity to 0. And then we have an interval of decrease, and that would be from 0 to +infinity. If we did talk about an interval of constant, again, this one would be none. So now looking at 6, again, domain and range. Domain is from the left-hand side to the right-hand side on the x-axis. So my domain would start at -infinity, and it goes to -1, and that's an open circle, so we have a parenthesis. And then I have a gap, so I'm going to use the union sign, and my domain begins again at +1 with an open circle, so parenthesis, and it goes to +infinity. As far as range goes, again, we read bottom to top, guys. It's an open circle at 0, so I have an open parenthesis, and we have arrows going in either direction, so we're to +infinity. We talk about intervals of increase, decrease, and constant. Again, we read that on the x-axis. So if I follow my function here, it is decreasing. So we are decreasing along the interval of -infinity to -1. And then we increase from 1 to infinity. If they ask about an interval of constant, we would say none. Looking at our last graph, again, domain and range is left to right. So my domain, the furthest left we start at, is -2, and that is a closed dot, so it's colored in. Bracket to +6, and that's an open dot, so we have a parenthesis. Our range is from bottom to top, so the lowest that this graph would start is at -2, and it goes up to 8. And I'm going to use a bracket because at 8, you notice there's a closed circle here and an open circle here. If one is closed, one is open, you always follow what's going on with the closed dot. Now our intervals of increase, decrease, and constant, we read from left to right on the x-axis. So if I follow my function downwards, I have a decrease from -2 to 1. So our decrease is -2 to 1. Then I stay constant. We have an interval of constant from 1 to 3. And then I have an interval of increase from 3 to 6. For number 2, guys, we're talking about piecewise. It's really important that you pay attention to what the shape of the graph should look like and then graphing. Both of these functions that we're talking about are lines. This first function, the slope here is +1, and the y-intercept is at 5. So on my graph, I'm just going to draw a quick graph. 1, 2, 3, 4, 5. Okay, so I have the intercept is at +5. 1, 2, 3, 4, 5. And it's a positive line, so it's going upwards. And I'm looking for the boundary that they gave me is -4. So I'm going to say 1, 2, 3, right here. This is the boundary I'm looking at. So this graph would go something like this in this direction. All I want is the stuff that is less than or equal to. So I have a closed dot here, and I want this part of the line. And everything else on my piecewise function, I would erase. Okay, we're going to do the same thing with our second function. Again, my slope here is 3, and my y-intercept is at -4. So go down here, -4. 1, 2, 3, 4. And then my slope is 3, so up 1 over 3. Down, I'm sorry, up 3 over 1, down 3 over 1 is going to be something like here-ish. So, and again, the boundary line that we're looking at is -4. So I have an open dot at -4, and it's going to go this way. All right, if I look at the second one, again, we have a function here. This is x plus 3, guys. My slope is 1. The y-intercept is at 3. So if I'm going to graph this, the y-intercept is at 3. I want, my line is going to look something like this. And 0 is our dividing point, or our boundary line. However, so I want everything less than 0. That is going to be on this side of my function, and I have an opened circle. Anything else, I would erase. So here I'm going to erase. And then I'm going to look at my second one. This happens to be a parabola. You guys are asking me, I don't know how to do this one. Make a table of values. Plug in -2, -1, 0, 1, and 2. Pick two numbers to the left of 0, two numbers to the right of 0, and then you can figure that out. So if I plug in -2, well, -2 squared plus 1 is 5. -1 squared is 1, plus 1 is 2. Wait. Yeah. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. So I have points at -2, 5, 1, 2, 3, 4. 1, 2, 3, 4. So -2 something up here, then at -1, 2, 0, 1, and then you notice it's just a mirror on the other side because it's a parabola. And I want all the stuff that's greater than or equal to 0. So that would be the stuff on the right hand side. So this is what your piecewise should look like. All right, determining if something is odd, even, or neither. You guys can use -x if you'd like to, or you can use numbers. I like to use numbers. So I'm going to plug in here, I don't know, -2 and +2, and then I'm going to compare my answers. So I have 2 minus 7 times -2. So I have 2 plus 14 gives me 16. Over here, I'm going to say 2 minus 7 times 2, 2 minus 14, and I get -12. I look at these two answers. They are not the same. They're not complete opposites, so my function is neither. Same thing over here. I'm going to say -3, +3. So I have -3 squared minus 2. So 9, -9 minus 2 is -11. Now I'm going to say +3 squared minus 2. So I get 9, -9 minus 2 is -11. These answers are the same. My exponent is an even number, so this is an even function. Over here, again, let's do 5 and -5. Just pick whatever number you want, and it's opposite. So I have the cube root of -5 minus 1, so cube root of -6. Over here on the other side, I have cube root of 5 minus 1, cube root of 4. Those are not exact opposites of each other, which would make it odd. So this is neither. All right, for the following functions here, when they talk about performing all these operations, you're given the f and the g, and they're asking you to do all of these things. So in this first question, they're asking you to add. So all you're going to do is take the f function, which is 7x minus 6, and add it to the g function, which is 4 minus x. If you're adding, guys, all you're doing is combining like terms. So 7x minus x gives me 6x, and then a negative 6 plus 4 gives me negative 2. And the second one, they're asking you to do two things. They're telling you to subtract, and then they're asking you to plug in 0, evaluate with 0. If it says f plus g, f minus g, f times g, anything of x, that means they want x to be in your answer. If they tell you they want you to solve this or evaluate it, whatever, with a number, then you're going to have a number answer. So in this case, we're going to subtract first. Order matters, so 7x minus 6 minus 4 minus x. What you have to do here is distribute this negative before you start combining. So 7x minus 6 minus 4 plus x. Combine like terms, I get 8x, negative 6, and negative 4 gives me negative 10. So I've combined here, and that's my answer for f minus g of x. Now if I want f minus g of 0, that means I take what I got for f minus g, which is 8x minus 10. I plug in 0 for my x, and I get the answer of negative 10. So again, if they want a numerical value, they will give you a number to plug in. Here, fg of x just means we're going to multiply. So you take the two functions, 7x minus 6 times 4 minus x, and you FOIL. 7 times 4, 28x. 7 times negative x, negative 7x. Negative 6 and 4 is negative 24. Oh, this is x squared, I'm sorry. And then negative 6 times negative x is plus 6x. So we combine like terms, write it in standard form, negative 7x squared. I have a 6x and a 28x is going to give me positive 34x. And then I have minus 24. Now lastly here, they're telling me to divide. So I take that f function, which is 7x minus 6, and I divide it by 4 minus x. There's absolutely nothing else I can do to simplify here, so that would be my answer. Now I have to find the domain of this function. Domain means my x values. There is a restriction here because the denominator cannot be 0. So I'm going to say 4 minus x. That value cannot be 0. I got to figure out what value of x is going to make my denominator 0. So if I add x to both sides, I find out that x cannot be 4. So my domain would be any number in the world except for 4. So the way that I would write that in interval notation is negative infinity to 4, union 4 to infinity. And notice I have parentheses on the 4 because 4 is not included. Now if we look at this next one, same exact thing. They're asking two questions in 5a. They're saying combine f and g, leave it in terms of x, and then they're telling you to evaluate it where x is 3. So if I'm going to first just combine the two functions. I have x squared plus 3 plus the square root of 7 minus x. There's absolutely nothing I can do to combine like term. There's no like terms to combine, so we're done here. In order to evaluate where x is 3, I take my 3 and I plug it into x. So I have 3 squared plus 3 plus the square root of 7 minus 3. 3 squared is 9, so 9 plus 3 plus 7 minus 3 is 4. Square root of 4 is 2. 9 plus 3 is 12 plus 2, and I get 14. So f plus g of 3 is 14. In letter B, they're telling me to take f minus g and leave it in terms of x. That means I'm going to have an answer that has x's in it. So my f function is x squared plus 3. My g function is the square root of 7 minus x. There's nothing I can do here to combine. This is it. All right, and the next one they're asking me to multiply. So I'm going to take x squared plus 3, and I'm going to times it by the square root of 7 minus x. And when I do that, guys, you can simplify here distribute, so you have x squared times square root of 7 minus x plus 3 times 7 square root of 7 minus x. And that's fine. In D, they're telling me to take f divided by g. So I have my f function of x squared plus 3 over my g function, which is the square root of 7 minus x. There's nothing else to combine or simplify or anything here, so I am done. This question up here asks me, what is the domain? Well, think about it. I have a fraction. Denominator cannot be 0. I don't have a specific one value because this will be an inequality because it's a square root. So I have to say, okay, the square root of 7 minus x, that entire expression has to be greater than 0. Not greater than or equal to, because if I take the square root of 0, I get 0, and I can't have 0 in my denominator. So what I just told myself was when I write my domain, I'm going to use parentheses around whatever the key point is. It's not included. So now I'm just going to say, okay, 7 minus x cannot be 0. What is going to make my denominator 0? What value of x? And that would be x equals 7. So what we did here is we found our key point, our critical point. 7. It's our tipping point. Where do I look? Do I need all the values on the left of 7, less than, or greater than? So I know I'm going to have an open circle, which is a parenthesis. Now pick a number on the left-hand side. I'm going to use 0 because 0 is less than 7 and it's an easy number to work with. So I take my function, 7 minus x, and I say, okay, 7 minus 0. Well, the square root of 7 is gross, but it's a real number, so stuff over here works. Now I'm going to pick a number over here, let's say 10. So I say, okay, I have my function 7 minus x, so I say square root of 7 minus 10, and I get square root of negative 3. Well, square root of negative 3 will not give me a real number. It'll give me an imaginary one, so that part doesn't work. So all of these numbers over here, from negative infinity all the way up to 7, will satisfy this function. So my domain is negative infinity to 7, and there's a parenthesis. It does not include 7. Okay, we have some more compositions and combinations. Guys, remember, this does not say fog. It does not say f times g. This says f of g. It can also be written like this, f of g of x. That means take the g function, plug it into the f. So in this first example, I'm going to rewrite my function so I can visually show you exactly what I'm doing. G of x is x cubed plus 1. I'm taking the g function. We work from the inside out. So I'm taking this g function and I'm plugging it in right there. So when I do that, I'm going to write my f function. I'll try and color code it here for you. So I have the cube root. Instead of x, I'm writing the entire g function. So it's x cubed plus 1. And then I finish the f function, minus 1. And now we simplify, guys. Well, negative 1, positive 1, 0. So I have the cube root of x cubed, which becomes x. Now I'm going to go down here and do g of f. That means g f of x. That means take the f function, plug it into g. So f is cube root of x minus 1. G of x is x cubed plus 1. So again, we're going to work from the inside out. We're going to take this f function and plug it in right there. So instead of x, I write the cube root of x minus 1 and then finish the function. So cubed plus 1. Well, when you cube a cube root, that cancels out. So I'm left with x minus 1 plus 1. Those two cancel, and I'm left with just x, just like I had up here. So now they want f of g of 0. This is saying, do the composition, take the f of g, which is what we did in the first step. F of g was x, so when I plug in 0, I get the answer of 0. And number 7, we're going to do the exact same thing. This is saying f of g of x, so take the g function, plug it in the f. So f of x is x cubed, g of x is 1 over x. So I'm going to take the g, plug it into the f. So my g function is 1 over x, and then I have to finish this, and it's cubed. Well, we distribute, the cubed goes to both. So 1 cubed is 1 over x cubed. Same thing, but opposite direction. I'm going to take g take the f function, plug it into the g. So my f is x cubed. My g function is 1 over x. So I'm taking the f and plugging it into g. So when I do that, I have 1 over, my f function is x cubed. Now they want to know, well, what is the f of g of 0? Well, we already did f of g, and we found that to be 1 over x cubed. So when I evaluate that when x is 0, I get 1 over 0 cubed, which is 1 over 0, which is undefined. Can't have 0 in the denominator. So when they ask for the domain of f of g, well, my denominator can't be 0. So it's not a square root or anything where I'm going to have a range of values. I'm just going to say x cubed cannot be 0. Take the cube root of both sides. X cannot be 0. So my domain is every single number in the world except for 0. So I would say negative infinity to 0, union 0 to infinity. And I'm using parentheses because 0 is not included. So that would be our domain for f of g. Okay, now we're talking about inverses. They want you to find the inverse. Well, remember, the first step to finding inverse is to cross off our f of x and replace it with a y. So I have y squared equals x cubed plus 2. Our second step is to switch the places of x and y. So I have x equals y cubed plus 2. And now we're going to just solve for y. So I'm going to subtract 2 from both sides. I get x minus 2 equals y cubed. In order to get y cubed, the cube to cancel out, I'm going to take the cube root. And what you do to one side, you do to the other. So you end up with y equals the cube root of x minus 2. And in order to write your answer correctly, we have to write it in inverse notation. So I would have f negative 1 of x equals the cube root of x minus 2. Find the inverse of the function. Again, same concept, guys, same thing. The first thing I'm going to do is cross off f of x, make it a y. So I have 9 minus x squared. Now I switch the places of my x and y, so it becomes x equals the square root of 9 minus y squared. And now we solve for y. So in order to get rid of my square root, I have to square both sides, because what you do to one side, you do to the other. When you square a square root, they cancel out. So x squared equals 9 minus y squared. Now we want that y all by itself, so I'm going to subtract 9 from both sides. So I have x squared minus 9 equals negative, careful with that, y squared. You guys with me? All right, so now we're going to we're going to divide out a negative 1 from both sides, which just changes the signs. So you have y squared equals negative x squared. Negative divided by negative is a positive. And then lastly, we take the square root. So you have y equals the square root of negative x squared plus 9. And we're not completely done because we have to write our answer in function notation. So it'd be f negative 1 of x equals the square root of negative x squared plus 9. All right, determine if there's an inverse. Here we go. First thing I'm going to do is cross off f of x and make it y equals 2 over the square root of x. Switch the places of x and y. So I have x equals 2 over square root of y, and solve for y. So I want to get y out of the denominator. I'm going to multiply this side by square root of y. They'll cancel out. What you do to one side, you do to the other. So this leaves me with x square root of y equals 2. Well, we want y all by itself, so we're going to divide both sides by x. I get the square root of y equals 2 over x. And then I want that squared, the square root to go away, so I'm going to square both sides. So I have y equals, remember, when you square both sides, you're going to square the numerator and the denominator. So this 2 goes here, and it goes here. So 2 squared is 4 over x squared. And I have one more step because I have to write it in function notation. So my answer would be, we have f, right? Is that what we did? Yes. My answer would be f negative 1 of x equals 4 over x squared. And that would be your inverse. Okay, now we have where we find the zeros. Guys, zeros is the same thing as roots, solutions, x-intercepts. All that means is we take our function, we set it equal to 0, and we factor. So I have 2x squared minus 7x minus 30 equals 0. A is not 1. A times C. Negative 60. What are the factors of negative 60 that multiply to give me negative 60, but add to give me negative 7? So if you don't know the factors you don't know right off the bat, just write the factors out. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And you can see here that 5 and 12 can somehow give me a 7 when I add or subtract. So I have my two parentheses, and I'm going to use 5 and 12. It's going to be a negative 12 and a positive 5 because negative 12 times 5 is negative 60, and negative 12 plus 5 gives me a negative 7. And since my A term is not 1, I'm going to divide out what's going on here. I have to use my A term to divide. So I see that 5 divided by 2 doesn't work pretty. So this becomes my coefficient. I have 2x plus 5. 12 divided by 2 is 6. So I'm left with x minus 6 equals 0. Then we set each parenthesis equal to 0 and solve. So I'm going to add 5 to both sides. I get 2x equals 5. Divide by 2. And one of my zeros is that x equals 5 over 2. And then over here, I'm just going to add 6 to both sides, and I get a 0, or a solution, or a root, or x-intercept at x equals 6. Moving over here, first thing I'm going to do is x minus 4 over 9x squared minus 4 equals 0. You don't have to do anything, and the only thing that matters is the numerator here. But if you want to go ahead and just solve, if I were to solve this, I want to get x by itself, so I'm going to multiply both sides by 9x squared minus 4. This cancels out, this becomes 0, so x minus 4 equals 0. Add 4 to both sides, and you have one solution. You have 1 0 at x equals 4. And then lastly, this problem. Guys, make sure you realize that this square root does not include the 1. The negative 1 is on the outside. So you have the square root of 2x minus 1 equals 0. First thing I'm going to do is add 1 to both sides. So the square root of 2x equals 1. Get that square root to go away. I'm going to square both sides. So I have 2x equals 1 squared is 1. Divide by 2. And this 0 happens to be at x equals 1/2. So there is your review all worked out. The answer key is posted under modules right under the test review itself. And I'm also going to have that extra help session Monday, September 7th at 3 o'clock. I sent you guys the link in your Canvas messages so you can access it there. All right, have a great Labor Day weekend, and I will see you all Monday or Tuesday.